Go. Section 7, it gets a little harder than Section 6, but the good news is that the answer is already given to you. The left side will always equal the right side. The left side will always equal the right side when we start these problems. When I have you prove something, your job will be to show me beyond a shadow of a doubt that you understand what you're doing. Now, how you're going to do that is some of you will have to show more work than what you've been showing. As I walked around the groups and I was looking at your work on some of the problems, some of you went 2 or 3 steps at one time, and you will need to make sure that you're showing me step by step how you're doing the problems. Otherwise, if I can't follow it, I will not give you full credit. So the way I grade, I have to follow. You have to make it slow enough for Mr. Paramo to understand. If you can do 2 or 3 steps in your head, guess what? Good for you. But if I can't follow it and you lose me and I can't follow what you're doing, then you're not going to get full credit. So make sure you are showing me step by step how you're doing things. Try to make it so easy that even Mr. Paramo can follow along. Okay? Trig proofs have a few differences. We have equations, and you are going to be doing things called one-sided proofs. And I want, this is underlined for a reason. You are not allowed to use both sides. You are only allowed to work on one side of the equation not at a time, but during the whole problem. During the whole problem, you can only work on one side, and I'm going to be very stringent upon all of you. If you try to do something on the left side and try to do something on the right side, you will get points deducted. You will not receive full credit. In order to get full credit, you will only work on the left side or only work on the right side. Period. This means you can't add or subtract something to both sides of the equal sign. It means you can't multiply or divide to both sides of the equal sign. It does mean that you can use identities or simplifying or multiplying by an equivalent expression of 1. I'll show you what I mean. You can choose to start either on the left side or the right side, doesn't matter, but I recommend starting with the side that looks messier. So let me show you what I am talking about. If you want to do number 2, sorry, high school, immature thought there. If you want to practice number 2 in your worksheet, you're totally welcome to do this along with me. I'm so sorry, my brain digresses sometimes. So here's the thing. I have this equation, and it's equal to 1, and that's the answer. This should equal 1. It's always going to have the answer with it. I'm telling you this is equal to 1. You are going to choose either the left side or the right side to work on, and you're going to prove that the left side equals 1 as well as the right side or vice versa. You have to pick only one side. Which side looks messier? The left side, does that look messier, or does the right side look messier? This left side, right? So we're going to start and try to make this left side equal to the right side. And what I can do and what I can't do. Do not divide by cosine squared of w. Why? Because then you're doing something to both sides. Instead, what we're going to do is we're going to look for maybe an identity. So here's what I want you to look at. I'm going to underline this little piece right here. Earlier, you were doing problems that had to deal with 1 plus tangent squared of theta. You should know what 1 plus tangent squared of theta is equal to using maybe a Pythagorean identity. What is 1 plus tangent squared of, not theta, of w? What is that equal to? If you know, tell the person you're sitting next to, please. So that is equal to secant squared of w. The way that I let Mr. Paramo know, or the person who is grading my test, that's me. Mr. Paramo, I know that this is equal to secant squared of W. I just did this little mark right there. You're showing me that you know that 1 plus tangent squared of W is equal to secant squared of W. Don't skip that little step. And then times cosine of W equals, and notice I'm not going to touch the right side. If I'm working the left side, I don't touch the right side. The right side is always equal to 1. And man, my handwriting's really bad. Cosine squared of W. Okay. Then what I'm going to do is I'm going to look at this. Man, I got to try to get it to equal to 1. So what I'm going to do next is I'm going to change out secant squared of W, and I know what its reciprocal identity is. Secant squared of W is equal to something. If you know what it's equal to, tell the person you're sitting next to, please. And then what you have now is you have 1 over cosine squared of W times cosine squared of W equals 1. And then if I'm multiplying them out, or if I want to show my work for Mr. Paramo to understand what I am doing, I am going to do this. And it goes in 1 time. You never stop until the left side is equal to the right side. I cannot stop right here, or I will not give full credit until I make this whole left side equal to 1, or I make this whole right side equal to the other side, like that. This is a proof. What you do not want to do is you do not want to skip steps. Do not go, 1 equals 1. Like, if I can't tell, you lose the majority of the points. These are 5-point problems. Like, that's what it's going to be. You see how it works? Do you have questions? Let's try one more. Oh, I have 2 more. I lied. But let's do number 5. Ooh, how do we decide which side is Messier? Sometimes it's a coin flip. Well, is the left side more Messier or is the right side more Messier? Maybe the left side? So you're going to choose one side. I'm going to choose the left side here. The left side looks messier. I'm going to mess around with it. That means the right side doesn't change. Equals cosecant of x minus cotangent of x. That's what I'm going to try to get this to equal. And I'm taking this whole numerator and I'm dividing it by sine of x. Maybe if I divide each term by sine of x, maybe something will happen. So I'm going to take the 1 and I'm going to divide it by sine of x. 1 divided by sine of x minus, I'm going to split it up, cosine of x divided by sine of x. I'm showing Mr. Paramo that I know that this can be divided by the bottom and this can be divided by the bottom. It means the same thing. I do not touch the right side. But I write out the steps to show Mr. Paramo that I know what I'm doing. Do I know what 1 divided by sine of x is equal to? What is 1 over sine of x equal to if I were to bring it up from the denominator to the numerator, tell the person you're sitting next to? Minus? Do you know what the cosine of x divided by sine of x using a quotient identity? If you do, tell the person you're sitting next to. Equals cosecant x minus cotangent x. Did the left side equal the right side? Did I only work one side without crossing the equal sign? Then what I did is correct. I knew what the correct answer is. This is called a one-sided proof. I see these things pretty easily. Some of you will have to try to do this without any aids. You have to, as I found out with one group was using some app on their phone to help them out. And I was like, we can't use the phone app. You need to start thinking about these and coming up with them from the top of your head. Number 14. Which one's Messier? It's hard to decide. But let me do this by a show of hands. If you want to work the left side, you're going to raise your hand. If you want to work the right side, you're going to raise your hand. So how many of you want to try the left side? Raise your hand. 2, 4, 6, 8, 10, 12, 14, 16, 17. How many want to work the right side? Raise your hand. 2, 4, 6, 8, 10. Oh, less by maybe 3 votes. So most of you are going to work the left side. So here we go. The right side stays the same. I am not going to touch secant of b or the cosecant of b. What I want you to notice is on the right-hand side, there's no plus sign or minus sign. So somehow we're going to have to get rid of this addition and subtraction. How am I going to do that? I might need to find a common denominator and then put these things together. So, as I told you in the previous set of notes, sometimes it's helpful to switch things to sine and cosine. Let's switch this to sine and cosine. This would be the sine of angle B divided by the cosine of angle B. Plus, let's switch this one into sine and cosine. What's on top? If you know, tell the person you're sitting next to. Over. So at this point, I haven't gotten rid of addition or subtraction yet. The only way to combine these two things when you're adding two fractions is to have a common denominator. So sometimes you're going to have to find a common denominator. Well, what is my common denominator? It's probably sine of b times cosine of b. I'm going to multiply this left side by an equation that's equivalent to 1. Is the sine of b divided by the sine of b, is that equal to 1? Do I have to do this to both sides over here? No. Because technically, I'm only multiplying this by 1, and anything times 1 is itself. This is why we wrote down in our notes, you can multiply by an equivalent expression of 1. I am technically multiplying just this left fraction by 1. Guess what that becomes? It becomes sine squared of b over the sine of b, the cosine of b. Now I don't have a common denominator yet, so I'm going to multiply this by an equivalent expression. I'm going to multiply by cosine of b over cosine of b. And I'm showing Mr. Promo all my work. Plus, so this multiplies to be cosine squared of b over sine of b, cosine of b. Do I have a common denominator? Can I put these two things together? I'm not touching the right side. So when I do that, I get this over my common denominator. I get sine squared of b plus the cosine squared of b over the common denominator of sine of b, cosine of b equals. And I'm not touching the right side. Now I see something. Now I have unlocked how to get rid of that plus sign. I remember a Pythagorean identity I could use. Pythagorean identity number 1. says the sine squared of theta plus the cosine squared of theta, or the sine squared of any angle plus the cosine squared of the same angle is equal to. And then Mr. Promo, I'm going to show Mr. Promo that I know that that's equal to 1. I'm just going to underline it, and I'm going to change that to a 1. I'm going to go over here, way up over here. 1 over sine of b, cosine of b, equals the secant of b times the cosecant of b. Now I'm going to split this up. 1 over sine of b times 1 over cosine of b. Guess what? Is that the same thing as the thing above it? I'm hoping you see the last step now. Do you know what this is equal to? Do you know what this is equal to? Can I do multiplication in any order? So I'm going to change this over here to cosecant of b, and I'm going to change this over here to secant of b. And guess what? Have I changed the left side equaling the right side? Have I proven that the left side equals the right side? Yes, beyond a shadow of a doubt. I didn't skip any steps. That is as hard as it gets. Now, with what I've done, you should be able to do problems numbers 1 through 15 on that worksheet. I am not going to talk about the other problems until next class. I will give you notes to do the rest of the problems later, but your homework tonight will be 7C.6, and you should also finish 7C.7, 1 through 15. That's what you should be able to finish up until this point. We'll stop your notes right there.